Hi class, let's take a look at problem 3. Now, problem 3, it's another messy graph, and here's the idea. Well, we're going to look at the behavior of the function as it approaches, well, on a, b, and c, it's 0. But notice that, well, if this is 1, this has to be 0. So therefore, here we're not going to have a limit actually be defined since you have a break on the graph and your y values are not going to be matching. So for example, as x approaches 0 from the positive side, that would be this side, your limit is equal to 2. So from the positives, you're equal to 2. On the actual, from the negative side, your limit is equal to 1. Remember that you're looking at the x's, but your final answer is the y values. So as you're approaching 0 from the right, that's going to be 2. That's here, and from the left you're going to end up with 1. Now this causes a minor problem because in order for the limit to actually be defined or exist, you have to have that both ends actually approach the same value. So in this case you would say that the limit does not exist That's technically our answer. If it's asking for a justification, then in this case, and let me write it in green, the limit as x approaches 0, and this is from the positive side of f of x, this is equal to 2, and it is not equal to the same value as the limit as x approaches 0 from the negative side, which is equal to 1, meaning on both ends, your function does not approach the same y value as it approaches to x is equal to 0. Now, let's take a look at the limit as x approaches 1 from the negatives. This is 1. From the negatives, we're going to get the values of 1. In this case, this is equal to 1. On e, we are looking at 1 from the positives. And in this case, notice your function is not defined, but your y value is also going to be 1. So this is equal to 1. And then on part F is asking for the limit as x is equal to 1. Actually, as x approaches 1. So let me just rewrite it. In this case, as the function approaches 1 on both directions, you're approaching the value of 1. So this one is defined. We don't have a problem on this particular one. That's actually it for this for this problem. Notice that in order for the limit to be defined on both directions as you're approaching your x value, you have to have your y values getting infinitely close.